Hello, everybody, and welcome. This is our Science and Technology series. Today, we are going to study about nanotechnology. Till now, we have studied about biotechnology and we have covered it from the perspective of prelims and mains. We will see various applications because of which you will be able to completely understand how nanotechnology is and how it will behave in the future and how currently its progress is. In the next lecture, we will be continuing with nanotechnology, right? So before starting, I would like to give you a perspective. Perspective means a viewpoint. Viewpoint, that means you understand an overall perspective of something. That is very important. Of course, we will be reading minute things, but you need to understand how to deal with the topic in an overall sense. So, this is a quotation by Professor CNR Rao. He was the chairman of Scientific Advisory Board to the Prime Minister. He said this statement in 2006. He said that we missed the semiconductor revolution in the early 1950s. We had just gained independence, but with nanoscience and technology, we can certainly be on an equal footing with the rest of the world. Now, this is a very important quotation because it gives India an opportunity, or basically tells the reader, like you and me and other people, it tells the reader that yes, there is an opportunity in which we can grow so much that we will become equal to the world, which is again a very basically a very good dream to have. And again, if we can accomplish it, we would become basically world leaders in nanoscience and technology. So this is how nanoscience is important. Now, why have I discussed this with you? Because this technology is growing. Similarly, biotechnology is growing. Similarly, artificial intelligence is growing. So if we focus a lot on these technologies and we try to come up with cutting edge technologies in these sectors, then we build capacity of our human capital. That means we train them, we provide them proper funds, we provide them proper research facilities, and so on. So basically, this quotation will be more applicable to your main examination part, right? So this you can use in your essay and apply to biotechnology and artificial intelligence also. So let us just quickly understand what it is and then we can move on to the application part. We don't need to mug up too much in this, but we need to know a lot. So keeping that in mind, I'll be discussing a lot of applications, but again, we don't have to go into any depth because we don't need to understand the technical details of it. We just need to know if it can be applied to certain field. So what is nanoscience? Or rather, first we should understand the nanoscale. So nanoscale is 1 to 100 nanometers. I will explain the comparison, don't worry about it. So what you have to do is just imagine. Imagine what? Imagine very small thing. Like if you have ever seen anything through a microscope, just imagine that. Think atoms, think size of molecules. So that is the level at which nanometer plays. So this is called nanoscale, the scale of atom, electrons, right, molecules. So at the nanoscale, scientists have seen that the fundamental components of matter, like atoms, molecules, electrons, they can be used to create new products. Okay, what do I mean by this? Please listen very carefully this part. At nanoscale, the properties or the way the things behave at nanoscale, they change. Normally, what we see in our real life is Newtonian physics, but at this scale, at such small scale, quantum physics also applies. Alright, we'll study about quantum physics in ICT section, but right now just understand that things behave differently at the nanoscale. Alright, so what scientists are doing is that they are trying to create materials at nanoscale so that scientists can utilize unique chemical physical properties that arise out because of the nanoscale. So basically, let me repeat again, at nanoscale, the particles behave in a different way. All right, the particles like electron, proton, all these things behave in a different way, and our bodies behave in a different way, but our bodies are made up of atoms only, right, and molecules. So at nanoscale things behave differently, and scientists are now trying to utilize those different properties to create new products like this. All right, so nanoscale is 1 to 100 nanometer. So what is nanotechnology? Nanotechnology, basically nano means the 1 to 100 Newton meter, basically small, right, very miniature, and technology is basically developing something out of it. All right, so this nanotechnology contains a lot of things. It has application of physics, chemistry, biotechnology, fabrication, and so on. We don't need to go into depth of that, but point is, it is now I have given you the scale also, like 1 to 100 Newton meter is the nanoscale. Then properties change at such small level, and scientists are now trying to utilize those change in properties. For example, let me give you an example here. Gold nanoparticle. Now it can appear in different colors. Although at normal particle, the normal gold particle has gold color, yellowish color, but the gold nanoparticle can appear in different colors like orange, red, green, and so on. Right? So another example, let me give you. Carbon nanotubes are there. I'll explain what they are. But carbon nanotubes are there. They have 100 times the strength of steel. That means, let's say you have 1 gram of nanotube, carbon nanotube, CNT, and you have same weight and everything is same. You have a steel sheet. All right. So this 1 gram carbon nanotube will be 100 times stronger than the steel sheet. So this is the effect of nanotechnology. Now, to understand the scale of smallness, listen to this. Now, compare Earth and a tennis ball. Okay, we both have seen this. We can imagine how big Earth is and how big tennis ball is. So similarly, if we place or if we replace Earth with tennis ball, okay, Earth with tennis ball, so 1 Newton meter will be this much. Basically, 1 Newton meter with as compared to tennis ball will be same as tennis ball compared to Earth. Getting my point? So read this statement. 1 nanometer is to a tennis ball what a tennis ball is to Earth. So imagine Earth, imagine tennis ball. So this tennis ball is basically nanometer of a compared to Earth. All right, basically nanoscale of Earth, because if you imagine a tennis ball, right, then you have to imagine that nanometer will be at this scale. At what scale? As small as tennis ball is to Earth, similarly nanometer is like a tennis ball in front of the uh, okay, I think it might have created a confusion. So just understand this simply. I'll explain this in one line. 1 nanometer, all right, compared to tennis ball is same as 1 tennis ball compared to the Earth. Okay, so this is how we can understand it. All right, also one more comparison, let me tell you. 1 nanometer is almost equal to 10 times the size of a single atom. Alright, another comparison can be, it is 10 times smaller than, like 1 nanometer is 10 times smaller than the width of the DNA. Alright, the width of the, this is the width of DNA. So 1 nanometer is like 10 times smaller than even that. Let me give another example. This is the human hair fragment. Alright, and you can see this yellowish things. This, pick up anything, pick up any one. It is one single carbon nanotube. Let's say this one. Alright, so this is the size. This is a human hair, and this is one carbon nanotube. This is how the comparison goes. I hope now you can understand the nano size. So why is there so much interest in it? First of all, like I've told you, they don't follow the normal rules that we observe in our day-to-day life. They have different properties. Secondly, at this scale, biology occurs. So basically, nanotechnology, we focus on man-made things, not on natural things. But again, this field is biotechnology, or nanobiotech also it can be called. All right. Okay. So please remember that they follow quantum physics and they do not follow Newtonian physics. They have very unique ways, and because of which when we operate at such small level, the properties change. The physical, chemical, electrical, biological, optical, these properties change of the matter, and because of which we can create new products. That is why also scientists are very much interested in nanotechnology. Now, another reason, okay, it imparts useful properties to material. It makes the material stronger. Like I've given you comparison between carbon nanotube and steel. Carbon nanotube is also very lighter. All right, obviously if it is stronger, then it is more durable, and then they also have different melting points. So basically you can increase or decrease the melting point of a material. You can enhance its electrical conductivity, like you can have more transistors on a chip. You can enhance chemical reactivity because they have large surface area. Nanomaterial, or let's say carbon nanotube, has large surface area, so you can increase the chemical reactivity. That means you can increase the speed of the reaction. But let me remind you what are the current state of technology. So basically a word of caution. That means don't overestimate the technology right now. So revolutionary products, all right, they are little bit in the future. All right, at least not 5 years even, but at least 10 to 20 years in the future, because a lot of research is needed before they can be given out to the normal public. Nowadays, what nanotechnology is, basically research is going on a lot. All right, a lot of research and development is going on in things to develop new products. Basically, the products that are there right now in the market under nanotechnology, they are not new products, but they are improved because of, let's say, applying carbon nanotubes. All right, by using some process which utilizes nanotechnology. So basically old products enhanced right now, like whatever is available, they are enhanced products. They are not something new that is totally created by nanotechnology. All right, we will see some actual applications also, don't worry about it. So word of caution was this, that real application are quite far in the future. So don't think that okay, one example that can be taken is many of you must have seen the Avengers movies. So Iron Man develops a nano suit, right? So all those things are way far in the future. Right now what we have done is develop some things by using particles like carbon nanotubes. All right, so quickly we'll be covering the applications part. This is very important because this technology has application in almost everything, as you can see. One of the most prime examples that I would like to give you is in the nano scale, right? Basically here you might be watching this lecture on your mobile, some of you, right? So the mobile has developed so much things, right? Or basically the technology related to mobile has developed a lot in the past 10 years, partially because of nano scale. Right now processors, if you look around, there are a lot of processors whose basically processors were coming of 14 newton meter in laptop. Now they are coming around less than 10 nanometer, right? In mobiles also, some are claiming that in the next year we will have 5 nanometer processors. So what are these things? These are being developed because of the technology, nanotechnology. All right. Smart watches, they are getting faster and better. How? Because we are able to create small processors. So all these things are being developed, which are there in our hand today, right? They are developed because of the technology that is given by nanotechnology. So let's start with the health and medicine part. So here I showed you a comparison between a hair and a carbon nanotube, right? So this is a carbon nanotube in a very close-up fashion. It is sort of a hollow structure which looks like a bamboo. Now this is a carbon nanotube which is being experimented in the treatment of cancer. Here the medicine will be delivered directly to the cancer cell. Right? So basically this is a nitrogen doped carbon nanotube for the treatment of cancer. So a lot of studies are going on in which they are studying the effect or basically using carbon nanotubes to deliver medicines. This was also asked in UPSC. Also, because of nanotechnology, our awareness or let's say our knowledge of tools is increasing. All right, people will in future will be able to quickly diagnose the issue. Right now, what issue comes? Mostly of diagnosis. Correct diagnosis is the most critical step. Many times, even personally, I have seen this. Sometimes people are not able to diagnose the issue properly. So tests might be developed, new tools, new scanners might be developed which can look into the body and give accurate results. All right. So this term or this technology will be nanomedicine. That means application of nanotechnology in medicine. All right. So what will be done? Diagnose properly, treat properly, and create new products or new medicines. In the future, one thing will come which will be personalized medicine. That means medicine according to your own genetics. Again, that is quite far in the future, but that is a very real possibility. So it will lead to better imaging and diagnostic tool. Like I told, there come new scanners. There might come a better way of blood tests, doing blood tests or doing biopsies, right? For example, gold nanoparticles, they are being currently used for treatment of cancer. All right. In one technique, people, the scientists have mimicked, they have created nanoparticle that can act like the good cholesterol, which is high density lipoprotein, the HDL1, right? It helps helps to reduce plaque. All right. So research is also being done on graphene. It is allotrope of a carbon. So to help spinal cord injuries. So basically, use of nanotechnology to help the spine. Then again, obviously, it will help in drug delivery, cancer treatment, repair damaged bones and tissues. All these research is going on. This is very important to know. Research is going on, and certainly one day it will help in it. All right. So basically, just one point. In better imaging and diagnostic tool here, when we get this, or basically it will help in like I said, personalized or individualized treatment, and also it will lead to better success rate. So basically it will save more lives, bottom line is. Now let's come to the environmental part. Here first let us see the water, how it will affect our water consumption or water availability. So nanotechnology can very well help in water purification. In future, things or basically what potable drinking water might not be available for everyone. That is a sad reality that we should face. So our administration is taking notice of this, and with Israel we have tried to partner on water desalination. So molybdenum disulfide, there is a membrane made of this. It can filter 2 to 5 times more water than the current filters. So basically it has more capacity, right? So this is because of nanotechnology. Then water detoxification. We need to purify the dirty water. Here also nanoparticles can be used to filter industrial pollutants. Especially those are dumped in the rivers directly. That can be treated through nanoparticles. Another new technique that is being developed is having magnetic water repellents. Where can they be used? Because it is water repellent, so it will not attract water, but it will attract the pollutant, like let's say plastic or oil. All right, so such things. Another thing is sensors. See, all these technologies, nanoparticles and even farming equipment work on sensors. So there will be some sensors which will be developed that can check for contaminants in water. All right, maybe in future you can drop the nano sensor in the pond and just see if the pollutant level is high or not, and maybe you can start fishing in that pond, something like this. So a lot of avenues are there in which this technology will help. Now let's come to air. Similarly, similar to water, air also needs filtration. So if you have seen, while if some of you have traveled through airlines, you must have seen that they have filters. All right, just before the flight takes off, when you are sitting for 5-10 minutes, they run the air filter, air purifier, and air freshener and everything. So they have filters in the airplane. So these filters are sometimes not that much capable. All right. With nanotechnology, now you can identify the chemical that might be more, or basically, if somebody is trying to, let's say, use some chemical or biological warfare, it can detect even that. All right. So one of the most practical example is NASA has developed some sensors which are deployed in smartphone of firefighters. So NASA has developed some sensors which were inserted in the smartphones of the firefighters to monitor the air quality around fires. So that helps them monitor the oxygen level, CO2 level, and have better rescue missions. Okay. Now let's come to the next part, which is construction. Nanoparticles, or basically nanotechnology, has been successfully used in construction, like to stop water seepage. Zinc oxide is being mixed in the concrete itself, and it combines with concrete and creates a very good layer which stops the water seepage. There have been some heat resistant nanomaterials which have been developed that block the ultraviolet and infrared radiation, right? So you will need to reduce, or you will need to use AC less and less, which is also good for the environment. Then one of the most important is titanium oxide nanoparticles. These are being used in creating anti-fogging windows, self-cleaning windows. All right. So nowadays glass is being used a lot in every office. Of course, for natural light, and it looks good, but it needs to be cleaned also. So that creates a problem. So to avoid that, titanium oxide nanomaterial is used as a coating which provides a property of anti-fogging. That means fogging will not develop. This will be particularly useful in the rear window of the, or let's say the back glass of the car also. Alright. Next we come to agriculture. Now here there is a lot of implementation. I have changed a little bit in the way I explain this. I'll be explaining via help of diagram rather than just boring text. So I hope you enjoy that. So as we know, development of agriculture is quite important for society as a whole, because to eradicate poverty and hunger, we need agriculture to function well. I'm talking about India. So we need to remove agricultural poverty, and of course nutrition needs to be ensured. All right. So basically we have to focus on productivity, agriculture productivity. All right. So this is the diagram. Now you don't have to mug it up, but again just try to follow what I am saying and you will be able to understand. Whatever you are able to remember, please try to remember it. Now this is a diagram which has potential applications of nanomaterial in sustainable agriculture practices. All right, we can improve crop productivity using nanomaterials in genetic engineering. Right, we can monitor the plant's response to fertilizers. Right, we can have sensors which are there in the soil, which can monitor moisture level in the soil, which can monitor fertilizer level in the soil. So whatever I'm telling, just try to remember that. All right, then in their nutrition, I'll explain the above part. In the nutrition, you can focus on or basically we can focus on increasing productivity by using the nano fertilizer and nano pesticide. All right, so basically nutrition supply. All right, regulation of nutrient. Then precision farming is basically using sensors to impart nutrients into the farming. So in precision farming, you basically see what the crop actually needs according to the land, and then you give it that. As it's not like you will give same amount of nutrition to every type of soil. All right. Then you protect them. How do you protect them? By plant-based resistance from pests. All right. Then biodegradability. We protect the environment by biodegradability of nanoparticles. Then regulation. You can regulate plant growth by giving it more nutrients whenever required. You can help them in adaptation to climate change. This is very important. All right, that's it. Now let me explain the above part to you. So agricultural inputs like fertilizers and pesticides, all right, if the nanotechnology is used, they'll become nano agrochemicals. Now by using optimum dose, we can increase the nutrition, we can increase the protection, and we can increase the regulation. Now nanoparticles when added with agriculture inputs, it becomes nano agrochemicals. Now adding nanoparticles separately like organic and inorganic nanoparticles, that also can help. Now nanoparticles when combined with biotechnology lead to targeted genetic engineering. You can change the DNA, RNA, you can change how it reacts to the environment. So basically it's a combination of agriculture, nanotechnology, biotechnology, and in the end it all leads to sustainable agriculture, enhance crop yield, and sustainable environment. All right, so this is how it relates. So in the end we have four things: agriculture, nanotechnology, biotechnology, and environment. So this is how we can combine all of these things, right? So this is a good diagram which you can remember also now, and try to see it 4 5 times, then you will be able to recall it in the exam also. So this can be used in mains also, it can be used to remember things in prelims also. Another example of a diagram. So this might be much easier to remember. Look at the center, nanotechnology in agriculture. So nano fertilizers, right? They help in crop growth. Nano biotechnology will help in crop improvement. Nano pesticides will help in crop protection. Nano sensors will help in precision farming. Nano sensors means sensors will be there in the soil. They will give message to your computer, and then with that you can reduce or increase the irrigation, reduce or increase fertilizers, pesticides, and so on. You can use nanoparticles to increase stress tolerance by you can basically, if the water or if the soil has a lot of salinity, you can put nanoparticles that might be able to decrease the salinity, like this. You can use nanomaterials to enhance the soil also and its health. All right, so this is how nanotechnology and things can be used to enhance the productivity of agriculture. All right, now let us see some guidelines. Now such things are mains oriented again, but since this is a course which has two components, prelims and mains, so I'll be taking both together for every topic, so it helps in better understanding. So this is a mains topic. So this is a guideline for evaluation of nano based agri input and food products in India. This is given by FSSAI, then Department of Biotechnology. All right, so what is the need of it? So basically nanotechnology and sustainable agriculture. I have shown you the link. We can use nanotechnology to have a sustainable practices in agriculture. That means we can protect the environment also, and we can increase the productivity also. Agriculture, more than 50% of the workforce is sustained by it. 17 to 18% of GDP is given by it. So to link both and provide direct direction and regulation, we need this policy, or basically guidelines. All right, so what are the objectives? It will help researchers in the development of products for agriculture and human consumption. So basically this document will guide how to do research. It will help regulators FSSAI. It will help regulators to assess the quality and safety of nano based agriculture, food and products. It will help Indian innovators and industries to develop new nano based formulation products. So basically three people will be differently helped, like researchers, regulators, and innovators, and basically developers. So researchers will be helped in terms of new products. Regulators will get proper regulations. Innovators will help. Innovators will get also get basic guidelines in which to develop things. Now, how it will be done? Data will be provided, like safety data, efficacy data, functionality, toxicity, and such data will be provided for nanoparticles, right? Nano NAP is here, it is given NAP and NAIP, nano agri input products. NAP is nano agri products. So you don't need to remember all these laws, but again, data will be given. All right. Then standards would be implemented by BIS or the BIS standards. So definition of nanomaterial is given by the guideline. It is explained what is nano agri input product. It is defined what is nano agri products. Okay. So those were the guidelines. Okay. So now what are the concerns regarding nanotechnology in agriculture? Now this is quite important because, as you know, nanotechnology is very small. It works at a very small scale. So it will definitely create issues because we cannot track such small particles. So there will be a risk. That means these small particles might get into our diet, this might get into our skins, this might get into our under, or basically under the skin, that they might cause toxicity, and we might not be able to diagnose it very quickly. Okay. So phytotoxicity and reactivity of nanomaterials in the environment and possible adverse effect on exposed workers. This means the toxicity created by the nanoparticles, agriculture nanoparticles, and how they might react to other plants, how may they react to soil, all right, how may they react to fertilizers. They have to be tested for everything basically, all right. So such nano products, when they will be developed, they need to be tested properly in every type of scenario before releasing for the public. Now, risk of nanoparticles toxicity is higher in plants especially because they can travel like in the plant's body easily, and then they can come into our body. So that is the bigger concern. Also, regulation is quite low or quite weak in the agriculture sector with respect to nanoparticles. Also, there is lack of knowledge. Now, whenever a new technology is developing, we obviously don't know how it is going to grow. So, lack of knowledge is there for proper risk assessment. There is lack of knowledge regarding proper risk assessment of the technology. Of what technology? Nanotechnology in agriculture. Right? Also, one very important thing in any genetic scenario is diversity. If we keep using what works, like if we keep using only one variety of rice or wheat, then obviously diversity will increase, and decrease in diversity is never good for nature. All right. Systems today that have developed, they have developed, or the immunity that comes in us also, it comes because of the various bacteria that we face in our life. If we live a very clean existence, our immunity will fall. That has been seen in the first world countries, right? Also, there was one argument that Indians have a relatively high immunity. That is why many people did not get affected by COVID. All right. So basically, what you need to understand is, if we keep killing the pests, if we keep killing the soil diversity, if we keep reducing the genetic diversity of the crops, then it is not good for the soil, not for the bacteria, even the good bacteria. All right, the rhizobacteria, which is a good bacteria, right, related to nitrogen fixation, even they will get affected, because we cannot decide, right? We cannot decide if one bacteria lives or one dies. If we spread so if we throw pesticide, then every animal dies. So lot of issues are there with respect to nanotechnology in agriculture, especially because it is related to the soil, it is related to us, because we eat all these products. All right. Then we come to energy. Here, carbon nanotubes will be basically are being used currently to make windmill blades that are longer, they are stronger, they are lighter than current, or basically blades that are used 5 years ago. So they will be able to create more electricity. Similarly, batteries are also being developed. We'll discuss about that. All right. So basically, new batteries are being developed that are that charge quickly, that hold more power, that are lighter in weight, and hence they give more power per charge. Also, film, a thin film, basically thin solar film or solar electrical panel is being developed that can be fixed on your mobile, all right, or even your clothes, so that you can generate electricity whenever you're walking, right? This is called piezoelectric, right? You can read about it. It's quite an interesting concept. So energy can be generated, or electricity can be generated by the friction or body heat, all right? Because of nanotechnology, coming to the next point, because of nanotechnology we are able to create more efficient lighting system. We can create more, or basically lighter vehicles, because of which the fuel consumption will be less. And just because the vehicles are lighter doesn't mean they are not strong. They are quite strong also. Okay, then glass coatings are there that will help in less demand of AC, like I discussed. So lot of applications in energy also, basically aimed at reducing the energy consumption and not energy production. Energy production is there, but it is with related to windmill. Otherwise, mostly it is to reduce the consumption and give the same output. Coming to food, in the food category, the benefits of nanotechnology are quite a lot, because as the technology is developing, we can apply it in every arena, like in processing of food, packaging of food, transportation of food. All right, there's a term called bioavailability, basically. Oops, sorry for that. So you can make food's nutrition available for the person who is eating it. All right, again, that's a technical thing. Just remember the term bioavailability. All right. So just a second. Food safety, that can be increased by having good packages by which you can protect the food. You can have food preservation by using biological nanotechnology based biological preservatives. All right. Now basically issue is, as seen in agriculture and now in the food that we are seeing, exposure to nanoparticle is going to increase. So health impact of nanoparticles is something which we are going to have to deal in the future. It will be a very big public concern. All right. So for this we need a uniform international regulation with respect to nanotechnology in food. So in food, while creating, you can talk about agriculture. While processing and while shipping, transportation, and consumption, you can talk about this diagram. All right. So nanotechnology, as you are seeing, it can enter into any sphere. Now let's talk about defense. In defense, you can use it in intelligence gathering. Like I've talked about sensors. You can have sensors underwater, you can have sensors on your border areas, you can have motion sensors, you can have atmospheric sensors which can detect some change in gases. All right. You can develop armor also, basically something like an Iron Man suit, but with carbon based material or carbon nanotube based material. You can have lighter weapons, because you can create new products or new lighter alloys by use of nanotechnology. If you have lighter vehicles, you will obviously be able to reduce the fuel consumption and you will be able to travel faster. Another thing that can be uh, helped in is medical treatment on the field of the injured soldier. So that is also quite important. There can be chemical sensors, like I said, to avoid biological attacks. And one of the new things that is coming up is lab on a chip. Basically, imagine like this: there is a doctor in the field, there is always a doctor in the field with the unit. So they might have a small machine on their in their pocket or on their wrist, and they will just have the blood of the person, or they can pick up any element they want to analyze and put it in that box or a chip, and then and there it will be analyzed. Now, how the thing that actually is done by big machines in a laboratory, that can be done on that small machine only because of nanotechnology. This will be done in the future, and it will be done based because of nanotechnology only. So basically, it will nanotechnology will reduce the weight and the volume, so it will help a lot of transport. It will help in a lot of transportation issues, and it will help in solving their fuel problems. Next, let us quickly see the challenges and issues with nanotechnology. See, nanotechnology and nanoparticles, they will disrupt the way things are being done right now, and they will help. Oh, sorry, they will have some or the other health impact. Obviously, they will also affect our environment. See, in health, we can see that right now also we can see plastics and microplastics, how they are affecting our ecosystem. Similarly, these particles are quite big. Sorry for ignore the word similarly right now. So plastics and microplastics are quite bigger particles. Nanoparticles are smaller than this, and we can't even detect them. So they will obviously help, or they will obviously help in some arenas, but again they will also increase the concerns, like they might be non-biodegradable. These new nanoparticles might become new non-biodegradable pollutants, and they will impact the environment. Like they might accumulate in soil, and then accumulate in our food, and then accumulate in our body. So such things will be there. All right. In environmental impact, you can also understand one more thing, that traditional filters might be too big for nanoparticles. So we might need new filters, new processes that can detect and destroy nanoparticles. Then there is information asymmetry. That means some people do not have any knowledge for this, especially people who are in policy making. They need to be made aware of the harmful effects of nanotechnology and the positive effects of it also. Alright, so we need to develop sufficient practical methods that can detect nanoparticles, and then we can reduce the effect of it. So basically we need to have reliable, safe and effective regulations. Okay. Next, there is lack of infrastructure and human resources. Of course, it's a new technology. Also, we are a developing country, so we don't have a lot of resources that can be put for these technologies as of yet. Of course, it should be done, but again, we have to work in the constraints of a developing country. Then there is high cost, because this is a growing field, so not many countries are able to invest in proper procedures, not able to invest in proper research, so that it proper policy can be designed, proper things can be created. All right. Governance issue is there, as this technology is something new, which has basically application in so many fields, as we have just seen. So what will happen is many ministries will try to regulate this technology, and that will create overlap issues. Then there are ethical concerns like biological warfare, chemical warfare. I've discussed briefly about this. Privacy, like micro cameras can be installed anywhere with use of small cameras are already created, but with the advancement of technology, it might become available to normal people. Then developing and underdeveloped countries will be disproportionately affected, because we know that many developed countries extract minerals from developing and underdeveloping countries and do not give the proper benefit to them. All right. Also, this was going on. Now what will happen is, they are at least extracting the mineral, and we are getting paid. But the point is, later on, the developed countries might just create some new particle that will mimic the rare minerals that are found in developing and underdeveloped countries. So this will lead to loss of revenue. Then, of course, I have discussed about biological weapons, gases, various. Let me tell you something. In future, there might be an creation in the form of a weapon where you can actually target a single person. How? By knowing their biotechnology or knowing their biology. Basically, you can take a hair sample from anybody and then design the uh, let's say small bacteria, design the bacteria to affect only you. So that can be done with the help of nanotechnology and biotechnology. So what to do? Of course, we need better regulation, we need flexible regulation. Why 2 points? Because why 2 points regarding regulation? Because this is the thing which can help the common person. Robust governance structure is needed. We need strong laws, policies, institutions. We need laws and policies and institutions that can enforce them. We need to make sure that companies think about recycling rather than just manufacturing blindly. We need to ensure equitable access. That means people should have equal opportunity of access. All right. So this is a document by a big company. Let's see what they say. See, it will promote renewable energies. Nanotechnology will promote renewable energies. It will make solar panels cheaper and efficient. It will extend the limit of electronics because unlike silicon microchip, nano chip will make it possible to build very precise circuits at an atomic level. So that will reduce the size of your mobile and also cost eventually. This might also lead to the mobiles that you have seen in movies which are transparent in nature or they have transparent screen. It will allow for a more effective medicine. Like damaged genes can be repaired faster. You can have more precise surgeries. All right. What are the disadvantages? It will help. Oh, sorry, it will threaten the environment because of toxicity and pollutants. It will have an impact on the job market because new skills need to be created and some old jobs will be destroyed. It might compromise the safety because nano weapons, like I just told you, personalized weapon, smart bullets that might just hit you. Like they can be launched right now. You have to aim at somebody to shoot them, right? But a smart bullet can be coated or made. Uh, it can be made in a way that it can attack only a particular person, like this. So this is very dangerous. So any new technology that is coming up, it has both positive and negative. So you have to remember that it's about how you use. All right. One more thing I'd like to explain: key aspect of nanotech governance. First, you have to have a inclusive function. That means you have to involve public and private sector. You have to involve international organizations also. You have to have a visionary function. That means you need to see where technology can go in the future and according to that change your policies. You need to have a responsible function. That means you need to assess the risk that this technology might have and then form solutions like ethical, legal, social effects should be measured and then proper policies. Transformative function, that means business policies, manpower production, all these things will transform from now to future. All right. So this is basically just for your reference. If a question comes in mains, you can use this thing, these four keywords: inclusiveness, vision, responsibility, transformation. So you can use these four keywords to basically this is a framework of keywords. So you can use this as a solution to any technological governance, right? So this is quite important. All right. So that is all for this lecture. Thank you for listening. We'll be continuing with some particular latest technologies in the next lecture, and we'll finish off nanotechnology. All right. So see you in next lecture. Bye bye everybody. Till then, take care and do revise.